Hello and welcome to 12.2. Here are the answers for 12.1 day 2. Working with inverse variation and writing inverse variation equations. Today what we're going to be doing is graphing rational functions. What we did yesterday, or in 12.1 day 1 with the graphing part, what we did yesterday was rational functions. They're all direct or inverse variation. These are going to be slightly different, but they're all basically the same. They're done the same way. We're just going to be moving our graphs left and right and then up and down. And then we're going to work on identifying the domain and range just as we've done in the past. I have done this example. This is the parent function, so I'm not actually going to do it. It basically looks like this was done in the previous video in 12.1 day 1, which is why I'm not going to spend time on it, but it looks like this. I'm going to talk about the domain and the range here though, so we can get a good start on that. So the domain is all the x values, okay, and we can't plug in 0 because 1 divided by 0 doesn't exist, but all these other numbers, 0 is the only number that I can't plug in. You can plug in any other number in for x here. There's not a number that you cannot plug in. So the domain is all reals except for x cannot be 0. It's every x value except for 0. And then if we look at our y value, so here's our y's up and down, okay? There's a y value here. There's a y value here, here, here. There's y values everywhere except for at one spot. There's no y value at 0 right there. So we say the range is all real numbers except for y cannot be 0 in this case. And this is going to be the case for the domain and range for all rational functions basically, for the most part. Except for the values are going to change. Okay, so let's start. Let's just talk about some transformations here when it says to compare. So when I see negative 2 over x, and I'm comparing it to 1 over x, the first thing I see is a negative sign, so that's going to be a reflection. You're going to notice this one here being in quadrants 2 and 4, and that's what we saw in 12.1 day 1. Now the 2, what that's doing is it's making the graph steeper, and we've seen that vocab term as well. That is our vertical stretch of 2. So that's what's going on with that one. And then over here we have 1 over 3x. Now what that's going to do is that's going to make your graph 1/3 the amount, meaning it's going to go up at a slower rate. The values are going to be divided by 3. That would be our vertical shrink. And so all of the same vocab terms we've talked about with other functions are going to apply here. We also have translations, vertical translations up and down, and horizontal translations left and right. So here we go. Let's get into this here. We're going to talk about the domain and range. We're going to make a comparison. We're going to do all that good stuff here. I have a plus 3 here. Okay, so what's going to happen here? We're going to figure out what value that x can't be. X cannot be 0. If I plug in 0 right there, it doesn't work. It's undefined. I'm going to choose numbers that I like. 1 and 2 and 3 gives me 0.3 repeating, so I'm going to choose 4. -1, -2, and -4. Okay, plug in 1. 1 divided by 1 is 1 plus 3 is 4. Plug in 2. 1 divided by 2 is 0.5 plus 3 is 3.5. Plug in 4. That gives me 1/4 plus 3 is 3 1/4. And then -1. No, they're not going to be just the opposites like they were in day 1 of 12.1. Plug in -1, you get -1 plus 3 is positive 2. Plug in -2, and you get -0.5 plus 3 is positive 2.5. Plug in -4, you get -1/4 plus 3 is 2.75. Now you'll notice here as x gets smaller into the negatives, -1, -2, -4, and -100, this gets closer and closer towards positive 3. As x gets bigger, 1, 2, 4, plug in 100, plug in 1,000,000, and x gets closer to 3. And the reason for that is we plug in 1 over, say, 1,000,000 plus 3. This is basically 0. So you're at 0 plus 3, and as you can see, it gets closer and closer to 3. But I'll plot these points and you'll see that as well here. 1, 4, 2, 3.5, let's see, 4, 3.25. And you can see here, the values are getting really close to 3 here. Without ever actually, it's impossible for it to reach 3. Because no matter what, this 1 over x part can never equal 0. It's impossible for it. It can be really close to 0, but it won't ever actually get to 0. Okay, then let's do the negatives. Negative 1, 2. Negative 2, 2.5. And if your graph doesn't have this shape, the negative 4, 2.75. So I'm getting, again, really close there. If your graph doesn't have that shape there, then something's wrong. Now, I should be actually really specific, and I should be including halves. This is something that I normally like to teach, half and negative 1/2. And the reason for that is, A, it's good skills, but it also shows more points. So if I do 1 divided by 1/2 plus 3, 1 divided by 1/2 is actually going to be, I'll show this here, 1 times 2 over 1, which is 2, plus 3 is 5. Okay, so a fraction within a fraction, that's what it turns out to be. And so if I plug in 1/2, that gives me 5, and you can see that that is right there, exactly where I have my graph. And then plug in negative 1/2. And I'm actually going to do this on the next example. Negative 1/2 divided by, 1 divided by negative 1/2 is actually going to give you negative 2. If you do 1 divided by negative 1/2 is really 1 times negative 2, gives you negative 2. Plus the 3 gives you 1, and as you can see right there, negative 1/2 comma 1 is right there. So there you go. Anyway, let's talk about the comparison. I have this one's just basically up 3. It's a vertical translation up 3. Okay, that's all. And the domain and the range down here. Domain is all the x values, but x cannot be 0. All reals except for x cannot be 0. Now the range is different this time. Here is our asymptote right there. The range is all reals except for y cannot be equal to 0. Basically, your domain and range are related directly to your asymptotes. Okay, let's get into this one right here. Now we have a number that's being subtracted with the x, and so it's slightly different. X cannot be equal to 2 because if we have 1 over 2 minus 2, that's 1 over 0, and that's undefined. And so this one is slightly different. So let's go with 2 here. That value is undefined. Now, again, I'm going to do 2.5, and I should have done this earlier. Actually, this would be 1.5, and then 1, and then 0, and then 2.5, 3, and then 4. Should have done that earlier. Okay, let's plug in some numbers here. 1 over 2.5 minus 2 is 1 over 0.5, or 1 over half, which is 2. 1 over 3 minus 2 is 1 over 1, which is 1. 1 over 4 minus 2, which is 1 over 2, or 0.5. Okay, so we got some good values there going already. I'm going to plot those. So 2.5 comma 2, 3 comma 1, 4 comma 1/2. Now you can already see right here on the you can see where your points are trending already. Now I know that that's where the curve is going to be, and I will explain how I know that in just a second. I'm going to plug in the other numbers. Notice how they're not negative. That's okay. So I plug in 1.5. I have 1 over 1.5 minus 2. That's 1 over negative 1/2, which is negative 2. Plug in 1. I have 1 over 1 minus 2. That's 1 over negative 1, which is negative 1. And plug in 0. 1 over 0 minus 2 is 1 over negative 2, or negative 1/2. Okay, so 1.5 comma negative 2 is right there. 1, negative 1 is right there, and 0, negative 1/2 is right there. And you can see your asymptotes already shaping up. They're taking place here. And so you have, again, here the x-axis is one of your asymptotes, and 2 is your other asymptote. Okay, so the reason why I knew that is that -2 right there. This one is a horizontal translation right 2. Okay, the domain is all reals except for x cannot be 0. No, x cannot be 2. 2 made it undefined. So this one's different. And then the range is all reals except for y cannot be 0. And that was this guy right there. So there you go. Ooh, this is something. I'm gonna check the time. Okay, I'm at 11 minutes already. I'm not gonna do any more graphing. We're just gonna talk about these last functions here. This -4 is gonna be a vertical stretch, and the negative part is gonna cause a reflection. So this one would be in quadrants 2 and 4. This one would be down 4. This one would be left 5. And the reason why I know it's gonna be left 5 is because x cannot equal -5 if I plug in -5. And so what that's going to tell me on my graph is that this asymptote is going to be right there because x cannot be -5. And then this one would be to the left 3. And the reason for that is x cannot be -3. So when you're going up and down, they're exactly what you think it'd be. The -4 in number 2 causes to go down 4, but when you're going left and right, just as we've seen before in the past, they're opposites. And when we meet up, I will use Desmos to show you guys some of these. So that's what they actually look like. Here's your assignment. Tune in, and I'll be going over some examples using Desmos, and we can chat more about these. Thank you guys.